we're talking about segments today. So first of all, a line segment is part of a line consisting of two endpoints and all points between them. So when we're looking at a line segment, we're not talking about the full line. A full line, we're talking about a line that extends forever in those two directions. But when we're talking about a line segment, it has endpoints where it literally stops at point A here and point B there. If we wanted to name this segment, well, AB with a line with arrows in both directions is talking about a line extending, but we want to show that it stops because this is a segment, and so we just simply put the line right there. We also could name it BA. The order of the letters really doesn't matter there because if we're talking about A to B or B to A, it's the same segment. It says here two geometric objects that have the same size and shape are called congruent. What a big word. It's the first time we've mentioned it here. Congruent segments mean it has the same size, or whatever this can be congruent shapes, can be congruent segments, can be congruent angles, but it's the same size and shape. Congruent is similar to being equal to, but we'll talk more about that as we talk about congruency. So here, AB and CD are considered congruent segments. They have the same length. They both have a length of 5. In this figure, AB and CD are congruent. They both have a length of 5 units. Congruent statement shows that two segments are congruent. There's our symbol. I'll write a little bit bigger. It's an equal sign with kind of the squiggly, almost, we think of that sign as approximately, but this means congruent. So AB, segment AB is congruent to segment CD, and that's what we see right there. In a diagram, congruent segments are shown with tick marks. The diagram below shows congruent segments indicated by tick. So check this out. If we want to mark on a diagram that two segments are congruent, well, we use tick marks. So we're saying that since this one has one tick mark and this one over here has one tick mark, we've now shown that QP we've now shown that QP, we can see since it has the same tick mark as RP. Yeah. So we can say QP is congruent to RP. 3 properties that are going to be very important and that almost seem so simple. I know your first instinct is, that's easy, I'm going to move on with my life. But no, you want to know these. First of all, we have the reflexive property of congruence. AB is congruent to AB. Reflexive is saying that something is congruent to itself. And that should make sense. A segment is going to be congruent to itself. The second one is the symmetric property of congruence. If AB is congruent to CD, then CD is congruent to AB. We have two different segments we're talking about there, and we can flip it around. If AB is congruent to CD, make that symmetric, flip it around, CD is congruent to AB. And finally, the transitive property, which may be the most useful here. If AB is congruent to CD, and CD is congruent to EF, then AB must be congruent to EF. So think about this more simple. Just if A is equal to, I'll use C, you also know that C is congruent to E, or equal. I'm just simplifying this. If A equals C and C equals E, then doesn't it make sense that A would equal E? That is what we're saying here, but we're just using our understanding of segments and congruence. If A equals C and C equals E, then bridging through that C, A must equal C. That is our transitive property. So, how do we remember these? Well, friend showed me once, hey look, we have reflexive, symmetric, transitive. F in reflexive, think of this as first, the S, it's like standing for second, the T, think of that as third. All right, first, we need one segment. We need one object we're talking about. AB is congruent to AB. Notice there's only one object in the sentence. Second, we need two objects. AB is congruent to CD. CD is congruent to AB. There's two different objects, the AB and the CD. Okay? Finally, transitive. Third, we need three objects. AB to CD, CD to EF, so AB to EF. Notice there's three. There's A, B, C, D, and EF. So that's one way to memorize that. But you need to know these three properties. So let's use them, identifying the property that justifies each statement. WX is congruent to YZ, so YZ is congruent to WX. We have flipped those two objects. This is the symmetric property. What is it the property of? It's the symmetric property of congruence, because we are using congruency symbols right there. B, PQ is congruent to RS. RS is congruent to TU, so PQ is congruent to TU. Well, we were relating two things to RS, so that means that PQ must be congruent to TU. There's three objects there. This is the transitive property. Of congruence. If we were using equal signs right there, it would be the transitive property of equality, but we're using congruency symbols. Finally, GH is congruent to GH. Well, one object, something is congruent to itself, it's using the reflexive property. So it may seem simple, but as we keep adding more and more vocabulary, as we add more and more theorems and postulates, you're going to want to have these down and really, really comfortable with these three ideas right here. All right, so I just said the word postulate. What is a postulate? Well, a postulate is a statement that is accepted as true without proof. Okay? These are things that are just so fundamental. We see them play out over and over and over again, but we're going to use these postulates to prove much more confusing things, I guess you could say, in geometry. But we have to have some very, very fundamental ideas. So here, the ruler postulate. This is our postulate number one, our first one right here, and this should make sense. That's what these postulates typically make sense. And so you're going to be tempted to just say, okay, that makes sense, and move on. But no, let yourself sit on it, make sure you understand it, and you're going to want to know these facts. The ruler postulate says the points on a line can be paired in a one-to-one correspondence with real numbers such that any two given points can have coordinates 0 and 1. The distance between 2 points is the absolute value of the difference of the coordinates. Okay, so we're talking about using a ruler to measure something, and what we're saying is you don't have to start at 0. You don't have to move the ruler to measure something. You know, if I have this big ruler right here, I don't have to measure this starting at 0 or starting at 1 or something like that. I can start anywhere, and I'm going to find the absolute value of the difference in the numbers. So notice right here on this one, if we want to find the length, the distance from A to B, well, we see that A is at 2, B is at 4. All right, it doesn't mean it's a length of 4 just because it stops at 4. No, we find the absolute value of the difference. This is the absolute value of -2, which gives us 2. This has a length of 2. And we can count right there. We can see, all right, this is 1, 2. does have a length of 2 units right there. So let's find all these distances. And notice our notation. I know it says it over here. If we want to find AB, well, there's not a segment symbol on top or a line symbol on top. If we don't put a symbol above 2 letters, this is saying we want to know the distance from A to B. That's what it's saying. So if we see, hey, if it just says, even if it didn't say find each distance, it just said find AB, well, it is implying that it wants us to find the distance from A to B. So if I see here A is at 6, B is at 3, well, the absolute value of the difference of 6 and 3 is the absolute value of 3, which is 3. So the distance from A to B is 3. The distance from C to D, well, C is at -5, D is at -1, so the absolute value of -1 minus a -5, -1 minus a -5, the difference of those 2 values would be the absolute value of +4, and the absolute value of 4 is 4. So the distance from C to D, 1, 2, 3, 4. That makes sense. The distance from B to C, well, from B to C would be the absolute value of 3 minus a -5. The absolute value of 3 minus -5 would be the absolute value of 8, which gives me 8. And AC, well, that would be the absolute value of 6 minus -5. So that'd be the absolute value of 11, which equals 11. Postulate number 2, the segment addition postulate. Again, something that should make sense to us. The segment addition postulate says if B is between A and C, okay, so B is somewhere between A and C, well, this segment AB plus this segment BC adds together to give us AC. This piece right here, if this piece is 3, plus this piece right here, if this piece is 5, adds together to give us the entire segment. And again, hopefully this does make sense. B is somewhere between A and C. AB plus BC gives me AC. So in this case, 3 plus 5 gives me 8. AC would equal 8 units. A says point T lies on RT between, point S lies on RT between R and T. Okay, I'm going to draw this. I would always draw a picture no matter how simple you think it's going to be. S is between R and T. RS is 12. RT is 31. This entire piece right here is 31. R to T is 31. We want to know what is ST. What is that missing piece? Well, the entire thing, let's set it up as they see here. Well, we know that RS plus ST must equal RT, right? The distance from RS plus ST must equal RT. We know RS is 12. We're looking for ST, and RT is 31. If we subtract 12 from both sides, we see that the distance from S to T is equal to 19. On B, we want to find AC in terms of X. We want to find the distance from A to C in terms of X. Well, that's going to be that piece right there, AB, plus 3x plus 9. We combine our like terms, we get 5x plus 2. And so AC, the distance from A to C is 5x plus 2. Last thing we're talking about here is a midpoint. And a midpoint is probably what you expect. A midpoint is the middle point on a segment. It is literally right smack in the middle of a segment. So it says a midpoint of a segment is the point that divides the segment into two congruent parts. If M is the midpoint of AB, well then we know AM is congruent to MB. That's what we should expect. Because M is the midpoint, it's separating it into two congruent parts. So let's look at an example. A hiker's traveling up a mountain towards the summit. The distance from the base of the mountain to the summit is 2.5 miles. How far will she have traveled when she reaches the midpoint Y? Well, if we know it separates it into two congruent segments, we know she's going to go halfway. We can take this 2.5, split it in half. Okay, 2.5 split in half would be 1 1/4 and 1 1/4, because we divide it in half, two congruent parts, they're going to be equal, that make up that whole, and so she will have gone 1 1/4 miles when she gets to the midpoint, which is halfway.